When talking about domain and range, the best thing to do is just to graph the function. So we'll start off with the first one, y equals 2x plus 4. The biggest exponent that we have for our x is the 1, so we know we're going to have a linear equation. So we enter this in 2x plus 1 and graph, and you can see that it's a straight line. So if we just change to a standard window, it's a linear function. Now, this line is continuing on this way, and it's continuing on in this direction. So we could assume that even if we expanded the windows, it would continue to do so. So let's do that. Negative 1,000 to positive 1,000, negative 1,000 to positive 1,000, and graph that. And same thing. So our line continues to expand in the horizontal direction as well as in the vertical direction. So the domain and range refer to all the possible values of x and all the possible values of y. So domain, since it continues to expand in the horizontal direction towards the left and towards the right, we say that x could be any number, and we write that as x ER, which is just a symbol that represents x as an element of real numbers. Because it continues to expand in the vertical direction, we can say the same thing about the y. So the range, we can say that y is an element of real numbers. Next one, B. We'll go back to a standard window and enter in our y equals square root of x minus 1. And then graph that. And here's our function. So we can see that it's only in this positive quadrant of our graph. So we know that there's going to be some kind of restriction on the x and y, that they can't be negative. So again, we can expand that window. Let's go further. We'll expand our maximums to 100. And you can see here that the graph continues to do the same thing. So I'll make that y max a little bit smaller, just so we can get a better look at the shape of the graph. So you can see that it continues to move out towards the right. So it's going in the positive horizontal direction, continuing on, but it's also getting taller as it moves out in the direction. So it's also moving up in the vertical. So in this case, it can be, it continues on to infinity, but it doesn't ever go below this point here. So let's go back to our standard window and see if we can figure out what that point is. And it looks like it's at x positive 1, but we can just use our trace feature actually to figure out exactly what that point is. So you can see here when we're in the negative, it's not showing up in our graph. We don't even have a corresponding y value. So when x is at 0, nothing. Keep going, and it looks like that point is at about positive 1. We can figure it out exactly by looking at number 1 value. When x equals 1, enter, y equals 0. That's the first point on our graph. So in this case, our x never goes below positive 1, then our y never goes below 0. So we have x greater than or equal to positive 1, and y is greater than or equal to 0. So this is our domain, and this is our range. Lastly, we have x squared plus 2. Graph that. And now we have a parabola. So same thing, if we expand our y maximum and make that taller and taller, we'll see that the graph continues to move in that direction. It's going taller in the vertical direction, but it's also getting wider. So it's expanding to the left and it's expanding to the right, to the right and to the left. So our x is going in both the positive and the negative direction, as well as our graph getting taller. So go back to a standard window, and we have to figure out what's that point down there. Our graph keeps getting wider and wider in the horizontal and vertical, or the positive and negative direction. So we know that our x could be any value. So domain, we have x, ER, but the range, our y values, although it continues to move on to infinity in this direction, it never goes below that point. So we need to know what is that point. We can calculate that by using our calc menu here, which we access second trace. And that's the minimum point on our graph because our parabola opens upwards. So we select number 3, left bound, move your cursor a little bit over to the left of the minimum point, enter, and then you move it just a little bit over to the right, enter again, and then enter for a third time, and it tells us that that point, when x equals 7.68 exponent negative 7, we can just round that to 0, y is equal to 2. So 7.6837 exponent 7 exponent negative 7, that's equivalent to 7 zeros being in front of this. So if we move this over 7 places, we would have 0.00000768, which we can basically just round to 0. So our range in this case, y has to be bigger than or equal to 2.